Dear students, today we are going to discuss an important concept of functions, that is sum of real roots of even function or odd function. Before going into details, let us first revise the definition of even function and odd function. Even function, a function is called even if for every x in the domain there exists minus x in the domain such that f minus x is equal to fx. Examples are x square, cos x, mod x plus 1 plus mod x minus 1, 2 plus under root 3 raised to power x plus 2 minus under root 3 raised to power x. Odd function is called odd if for every x in the domain there exists minus x in the domain such that fx is equal to minus fx. Examples are x, sin x, x cube, mod x plus 1 minus x minus 1, log under root x square plus 1 minus x. Now sum of real roots. The sum of real roots of even function or odd function is 0 with the conditions: the function must have some real root. The domain of function is symmetric. Multiplicity of roots is taken care of. If the function does not have any real root, we say that sum of real roots is not defined. By definition, for even function, f minus x is equal to fx. For odd function, f minus x is equal to minus fx. If there is a point in the domain x is equal to x1 where fx1 is equal to 0, then by definition of even function or odd function, f minus x1 is also 0. Thus, even and odd function have roots in pairs of opposite sign, except 0 is equal to 0. The condition of pair is also applicable for multiple roots. Sum of roots of even function or odd function is 0 if the function does not have any real root. It is said that the sum of real roots is not defined. Multiplicity of roots should be taken care of. Each multiple root should be cancelled out by its counterpart of opposite sign to get the sum 0. Now the examples. The sum of real roots of equation x square plus 4 is equal to 0 is 0, 1, 2. Sum is not defined. We have the function x square plus 4. Let us first see whether function is even or odd or neither. Replace x by minus x. F minus x is again x square plus 4, which is equal to fx. The function is even function. Let us see whether the function has any real roots. For fx is equal to 0, x square plus 4 is equal to 0, x square is minus 4 and x is under root minus 4. The function does not have any real roots. The sum of real roots of function is not defined. Next question is a function defined as below: fx is equal to 2 minus x for x greater than 0, minus 2 minus x for x less than 0, not defined at x equals 0. The sum of real roots of function is 0, 1, 2, not defined. Let us first check whether function is even or odd or neither. For x equals 0, x is greater than 0, fx is equal to 2 minus x. Replace x to minus x, f minus x becomes 2 plus x for x less than 0, which is minus fx for x less than 0. This is the condition of odd function. Similarly, for less than 0, x less than 0, fx is equal to minus 2 minus x. At x less than 0, replace x by minus x, f minus x becomes minus fx again for x greater than 0. For domain x greater than 0 and x less than 0, the condition of odd function is satisfied. For domain x equals 0, fx is not defined. For odd, we know for odd function either f0 is equal to 0 or f0 is not defined. Hence given function is odd function. Let us check whether function has any real roots. In the domain x greater than 0, if we put fx equals 0, the solution is x equals 2. Hence x equal 2 is at least one root of the function. Since the function has one root, at least one root, sum of real roots is 0. Option A is correct. Next example is the sum of real roots of fx equals x cube minus 5x is 0 plus under root 5 minus under root 5 not defined. Given function x cube minus 5x, replace x by minus x, f minus x becomes minus fx. The function is odd function. X equals 0 is at least one root of the function. Hence sum of all real roots of function is 0. Next example is the sum of real roots of function fx equals sin x is 0, infinity, minus infinity not defined. Given fx equal to minus fx equals sin x, if we replace x by minus x, f minus x becomes minus fx. This function is odd function. It has at least one root at x equals 0. Thus the sum of real roots is 0. Option A is correct. We should explain this question in detail. The roots of the function are x equals minus 3 pi, minus 2 pi, minus pi, 0, 5, 2 pi, 3 pi. The sum of roots are infinite and their sum is 0. Next question is the sum of real roots of function cos x minus 1 3 is 0, pi, minus pi not defined. Given function fx is equal to cos x minus 3, it can be proved that it is an even function. To derive whether the function has a root, let us compute range of the function. We know range of cos x minus 1 is to 1. Range of function cos fx equal cos x minus 1 by 3 is minus 4 by 3 to 2 by 3. 0 is an element of range of function. Thus function has at least one real root. So the sum of real roots is 0. Next question is the sum of real roots of function mod x plus 1 plus mod x minus 1 minus 2 is 0, infinity, minus infinity not defined. In the given function, we replace x by minus x. F minus x becomes mod 1 minus x plus mod minus x plus 1 minus 2, since mod of minus a is equal to mod of a. So f minus x can be proved to be fx. Thus the function is even function. Now we are to check whether it has at least one real root. We may do so by drawing graph of the function. Let us check values of function at critical points. The function has two critical points, x is equal 1 and x equal to minus 1. Value of function at x equal to 1 is 0. Hence s is equal to 1 and x equal to minus 1 are at least two real roots of the function. So the sum of roots is given. So, sum of roots is 0. Let us go in detail. For x less than minus 1, fx is equal to minus x 2x minus 2. For the domain minus 1, fx value is 0. For x greater than 1, fx is equal to 2x minus 2. This is the graph of the function. This line is y is equal to 2x minus 2. This line is y is equal to minus 2x minus 2. And in the domain minus 1 to 1, the value of the function is 0. If the function has infinite number of the roots from minus 1 to 1. The count of roots is infinite. Every positive root has its counterpart in equal quantity of negative sign. Hence, although the number of roots are infinite, yet the sum of roots tends to 0. Next question is the do-it-yourself question. A function is given by fx equals mod x plus 1 plus mod x minus 1 plus alpha, where alpha is a real number. What is the value of alpha for which the sum of roots of fx is not defined? In other words, it does not have any real root. Next question. The sum of real roots of fx equals 2 plus under root 3 raised to power x plus 2 minus under root 3 raised to power x minus 14 is 0, 2 minus 2 not defined. Given function is can be written as 2 plus under root 3 raised to power x plus 2 plus under root 3 raised to power minus 14, because 2 minus under root 3 and 2 plus under root 3 are reciprocal of each other. Putting x to minus x, f minus x becomes equal to fx. Hence the function is even function. Now we need to know whether it has any real root. We can see 2 plus under root 3 raised to power x plus 2 plus under root 3 raised to power minus x is a phrase like a raised to power x plus 1 by a raised to power x, whose range is 2 to infinity. Here a is greater than 0 and a is not equal to 1. Hence the range of the function is minus 12 to infinity. 0 is element of this range. Hence the function has at least one real root. The sum of real roots of function is 0. Next question is do-it-yourself question. Let there be a function fx equal to 2 plus under root 3 raised to power x plus 2 minus under root 3 raised to power x plus alpha. What is the value of alpha for which fx has two distinct roots whose sum is 0? Next question is sum of real roots of function fx equals log under root x square plus 1 minus x. 0, e, 1 by e not defined. It is do-it-yourself question. Hint is the function is odd function. Thank you for watching the video.